Are you doing a lot of charging? Hey, what's going on YouTube? If you look back at my channel, one of the first videos I did was how to convert this PC power supply into a desktop or benchtop power supply that you can use to run your electronics projects, or in my case, why I converted it was to power up an RC battery charger. I started off with the AccuCell 6 charger, which I used on this, and it works fine. It's just it's limited, right? So this will do up to where does it even say here? 6 amps. So you can charge 6S batteries, but up to 6 amps output. The wattage, I believe, is 50 on this. It's not even, I don't even see it on the front, but so it'll charge your batteries, even do maybe a little parallel charging, but just not at a very high amperage rate. So if you start flying a lot of packs and maybe parallel charging, or you want to parallel charge multiple large batteries, you might quickly run into the limitations of a smaller charger like this and or power supply like that. So what I'm going to show you today is what I've done recently, and if I would have known about this at the start, I may never have gone down that route. I may have just started with what I have now. So I'm going to show you and explain what I did. Alright, so this right here is a power supply that's been taken out of a computer server. There are servers all over the world, right, running every website that you visit, and because they need to be up all the time, they have many power supplies in redundant connections, and because they don't want the website to ever fail due to a powering issue, they have a cycle time on these, so they get swapped out at a certain number of hours of runtime, whether they're bad or not, and most of the time they're still working just fine. So I picked this one up on eBay. Actually, I picked up 2 of them, and they were incredibly cheap. I believe I got the 2 of them together in one order. I want to say it was like $25. I'll try to look up my eBay purchase. It was a couple years ago, so I don't remember exactly. I'll try to look it up and flash the total that I actually paid on the screen, but I know it was under $30. I think it was like $25. I got this idea after seeing a video on YouTube. I will link the video down in the description. It was an extremely well done video. I believe it was from a channel called rchelp.com, and it's a guy explaining their forum posting about how to convert these over for safe use, so that you can actually put them in series and get a 24 volt power supply out of it. So the reason these are really cool is because by itself this is a 12 volt power supply, and we'll just look at the labeling here real quick. So that's the model number there, the 701072-Y00. That's quite a mouthful, but what you can see is that it's a 12 volt power supply that can output 62 amps on the 12 volt. It also has other connections if you needed 3.3 and 5 volts, but I'm just using it as a 12 volt supply, and actually I'm putting it in series with the second one so that I can make a 24 volt power supply to be able to extract full power out of my charger nowadays. I'm no longer using that AccuCell. I have an iSDT smart charger that's capable of 500 watts approximately. So what I'm going to show you on how I set this up, I do just have to start and say from the very beginning, just as that other video did, I'm going to show you what I did and how it worked for me. I do not guarantee that it's going to work the same for you. The condition of your power supplies, if you go this route, they may be different than the condition of the power supplies that I ordered. This can be dangerous if you don't do everything properly, if you don't know what you're doing, and so I am in no way responsible if this does not work out for you or you hurt yourself. You have to proceed at your own risk. That being said, many people have done it. There is a very large forum thread on RC Groups, which I will also link that thread down in the description. I pulled a couple diagrams out of that thread on RC Groups, which helped me get this one set up. The original video that I saw for rchelp.com, which inspired me to try to do this, he was using HP power supplies, and I ordered Dell's. That was my mistake. I thought I was ordering the same ones he did, but there was so much time elapsed between when I saw the video and when I placed an order, an auction order on eBay. I just screwed up and I bought a different type, and I didn't realize till they arrived. However, this one is covered in that RC Groups thread, and during this video, when the time comes up, I'll put the diagram that I used to help determine the pin out. I'll put that up on the screen. So it was relatively simple. So let's talk about the safety concerns here. These put out a lot of power. Alright, so this one is 750 watts, I believe. Where did I see that on here? Yeah, 750 watts is what it can put out at 62 amps. More than enough amperage and wattage to power up our chargers and do the batteries that we need. However, these are made to plug into a server rack. Okay, so even though I've modified this without the bullet connectors and the jumpered wires and everything, this is made to plug into like a bulkhead connector on one end of the server rack, and you get your 120 AC coming from the wall outlet coming in here. So this basically takes the AC coming in on this side, does what it does throughout the body, and converts it to DC that the computer needs, or that in this case that we need for RC charging on this end. Since this was made to be slammed into a bulkhead connector, none of this, there's like no switches on this thing to turn it on. So in order to get it to work, you have to figure out which ones of these pins would have been activated in the bulkhead connector in order to power up the supply. So that would have been a long process of trial and error if it weren't for some of these forum threads that I had found and the postings. So what I'll show you right now is a close-up of this end over here, and we'll talk about what you got to do to get these things to power up. If you're only going to use one as just a 12-volt supply, then it's relatively safe. All you have to do is the slight pin modifications over here in order to get it to power up when you plug in the AC outlet over here. You only need to worry about the real safety issues if you're going to use two of them in series to produce 24 volts. In which case, you've noticed I say DC float on this one. I have had to open this one up and modify it internally in order to make it safe to use with another power supply hooked up in series. I took some photos of that process, so I will go through and show those pictures and tell you what I did at each stage. It's relatively simple. Basically, real quickly, on the bottom, you just end up having to remove two screws that hold down the circuit board internally, because those two screws ground the DC section of this power supply, not the AC section over here, but the DC section grounds it to the chassis. And if you have a bare metal chassis touching another bare metal chassis of a second power supply, they at best are not going to work, and at worst they could short out and cause some sort of fire. So that's where the danger comes in. You have to know what you're doing, and once again, I am in no way responsible for if this does not work out for you, and hope to God you don't get hurt. But if you just read through the forum threads, lots of people have done it. It's pretty simple. So let's look at the end here and show you what I did first to just activate a single unit. Okay, so now we got a close-up view here of the bulkhead connector. You can see you have several rows and columns of pins here, and then you have there's 6 sets of blade connectors over here on the right side. Again, like I said, there's no protection. I cut some of this plastic away, but this is really not meant to be touched by human. So you ended up with the 3 positive blades right next to the 3 negative blades with nothing in between, so it was very easy that something could have crossed over those and shorted out the supply. I've done some stuff to try to protect for that in the future. But anyway, in order to get this to even turn on, you have to jump a few of these pins. So you'll notice that there's 4 rows, right? You can kind of see over here. 1, 2, 3, and 4. So there's 4 rows going left to right, and 1, 2, 3, 4, 5, 6 columns. 6 column of pins right there. So in order to get this to turn on, and I will try to put the image up on the screen right now, you have to jump or connect a certain number of these pins. Basically, the very bottom one on this first column and the second one, so the very bottom here, next one up, and then over on this side you need not the very bottom one but the next one up. So if the ones on the bottom say are number 1, then on this last row, or sorry, last column, you need pin number 2, and on the first column you need pins number 1 and 2. You have to put those all together to get the thing to turn on. In my case, what I did is I just pushed pin number 1. I pushed it up a little bit till it was almost touching pin number 2, and then I put a little dab of solder on the pin tips and holding them together. As you can see from this wire, this is just a wire removed from a servo connector. So I put the little metallic part of from the inside the servo connector down on this pin, cut the wire really short, exposed a little bit of the wire, and dabbed it into that solder joint on this side. So that gets the thing to turn on. Now you can see here there's a fan, and the fan has no grill on it at the moment. I'm hoping to remedy that in the future. But again, there's no grill on this because this whole end of the power supply is usually stuck in the rack end of the server rack, so you never, the bulkhead side rather, the bulkhead end of the server rack, so there's no human to be over there and get your finger cut off by a fan or whatever. But this thing runs super loud. It's at full power pretty much all the time. There is a way to regulate the speed of the fan, putting a resistor on a certain of these pins. I didn't go that route. I went with a simpler method that basically just cuts the fan down to, I believe, medium speed, makes it much quieter, and it still provides more than enough cooling on this supply. And the way that you kick the fan into low speed versus full speed when you first power it up, if we go back to the pins here, on this second column, not pin number 1 but pin number 2, kind of covered up by this wire right now, you bring that one into the soldered group as well, and that one slows down the fan. So it's still noticeably noisy. I mean, the fan running, you can hear it, but it's definitely not as bad as it was when you first powered it up. So if we go back to our numbering and convention again, if we say that the pins on the bottom, that's number 1, next one up is 2, next one up is 3, next one up is 4. On this first column, we had to connect pin number 1 and number 2. On the second column, we connect pin number 2, and then on the 6th column, we connect pin number 2. So if you connect those 4 pins, then this will power up and have the slow fan, so it's not as noisy. If you do all that, when you plug it in, you will get 12 volts. A little bit more, usually like 12.4, between the negative portion and the positive portion. So there's blade connectors here. Actually, let's look from above. Okay, looking from above, you can see there were 3 blades here and 3 blades here. And so this is the negative side, that's the positive side. What I've done is I kind of squeezed open the middle set of blades, just enough to pop in a 4mm bullet connector. and then I used some needle nose and kind of grabbed all of the blades together and compressed them down as tight as I could get them, holding that bullet connector in, and then soldered it. Same thing on the positive side. Just got it nice and hot, big tip on the soldering gun, and soldering iron rather. It's not a gun, I don't have a gun. Used some flux to make sure it would penetrate in there and the stuff was all clean, and they're holding pretty well. They are pretty strong. Wiggle the whole thing by that. So then, to protect the ends, I've just liquid electrical taped all the exposed soldered edge on this outside, and then capped them off with some shrink wrap, which I cut off even. So that's the exterior portion of the modifications here. Like I said, I didn't video when I was opening this up to show you the process, but basically, let's look at this one. And again, this only applies to this model here. That's the one I've ordered, the Dell model model 7001072-Y003. I think this number up here is like the server model that it usually goes with. But I think you have to remove 6 screws. So 1 there, 2 there. Oops, sorry, 2 right there. This one, that's actually a rivet. So they'll remove those 2. This one. On the top here, you do not have to remove that. That goes to the like a fan connector. And on the other side, you've got 2 up here by the bulkhead side, 1 in the middle, and 1 in the rear. So remove those, then the top will come off, and it exposes the circuit board. It goes all the way through, and for that one, there's 5 screws to worry about. So the first two screws going through the circuit board, closest to this bulkhead end, those are the 2 you have to remove to make it safe. Alright, so here you can see a picture of the circuit board inside the power supply, and the screws that you need to remove to make it safe are the ones on the left by the bulkhead connector. You don't need to touch anything on the right hand side by the AC connector. Here's another picture, more close-up picture showing the 2 screws that you need to remove over by the bulkhead connector. These are the 2 that will complete the ground between the circuit board and the chassis. And here's a picture of the bottom of the circuit board with the entire thing removed from the case, and the 2 red circles indicate those same 2 screw holes where you're going to need to remove the screws in order to float the DC ground. And here's a close-up picture of those 2 screw holes from below once again. Just insulate these. Those are the 2 screws that are grounding the circuit board to the case itself. These over here, that one is the bottom of a screw, and this is also the bottom of a screw. This might be the where the AC ground is also attached. So 4 screws holds it down. I remember there were 5 screws. So 4 screws holds the circuit board to the bottom of the case, and then there's 1 more screw internally, which basically connects the ground pin on your AC side to the chassis as well. So you just have to remove the DC ground from 1 of these if you're going to put 2 of them together to do 24 volts and put them in series and get 24 volts. If you're only going to use 1 supply as a 12 volt supply, you do not have to mess with the DC grounding. all you'd have to do is the pin modifications over here to make it turn on. Okay, so now we're back. There's the two supplies right there. You'll notice that one of them is covered in heat shrink. So when I was first watching these videos, they were making a big point of if you didn't float the DC ground or remove the DC ground from one of them, then there's no way that you could use two of them in series without, if they were touching, you would possibly short everything out, and that could be bad. So at first I thought, well, as long as I physically separate them, they can still be side by side and it should work. So I had the bright idea to get some shrink wrap, or so I thought it was a bright idea, to get some heat shrink and just cover each one of them in heat shrink. So this is this was a little too big, but this is 120 millimeter heat shrink. I got it from Amazon. So I covered each one in heat shrink and thought I'd be safe like that. So they worked independently. That's fine. Each one would produce 12 volts, no problem. Oh, so you can see here I've done two of them exactly the same. But when I tried to connect them together, it wouldn't work. One of them would shut down, and so that was, I mean, in hindsight, that was good for me because that was exposing a problem. Rather than shorting out and possibly going into, causing a fire or something, just one of them would shut down. On the back here, I would get one of these lights. The little yellow warning light would come on, and it would just shut down. So much preferable to shut down than to blow up, right? So the reason that was happening is because inside the case, back here on the AC part, both of them, even though they were covered in heat shrink and not able to physically touch each other, the cases are grounded to that AC lug for the grounding on the AC part, and on one of them the DC, well, they were both at the same time. I hadn't removed the screws for this one, so the DC grounds were still intact on both of them, even though they were not able to physically touch one another, and the AC grounding is also connected to the case. So in effect, they were still, the DC to DC grounding was happening, and luckily one of them was just shutting off. So I did have to cut the shrink off of this one, open it up, remove those two screws. I just used some pieces of the heat shrink. This is kind of thick rubber. It's not that plasticky heat shrink. I removed the screws on this one, the two screws closest to the bulkhead end, and I used my multimeter to verify that there was no longer continuity between the circuit board and the chassis, the case here. But I took the pieces of this heat shrink, this rubber, and slid it right over those areas and glued it down with hot glue so it's not moving. Then I put the circuit board back in, put the case back together, and now they work. So what I'll do now is I'll plug them in, and you can hear when they start up, the fan comes on at full speed. It's a little loud, but then the fan like calms right down, and it's barely a whisper after that, and it still flows enough air. You can feel it coming out of the back here. It keeps them more than cool, so there's no issue with overheating. So let me plug these in and you'll hear how it goes. Alright, so the camera, I'd say probably about 1.5 feet away from them. You can hear those fans. It's not too bad. And again, just as a word of caution, in addition to the warning I gave at the beginning about be careful when you're doing this, I am in no way responsible if things go wrong with your setup. But just in general, when you're charging LiPos, charging any RC type battery for that matter, don't leave them unattended. Always be present. Charge them in a battery bunker if you have it. a metal box of some sort, cinder blocks, at the very least a LiPo safe bag, and don't leave them alone. Always be present, because you never know when something could happen, something could go wrong. You need to be there to put the fire out. Alright, so that being said, let's look at the voltages we can get out of these now. Alright, so we'll look at the voltage we can get. So 12.37 on the one, 12.3839 on the other. Okay, so independently they're great 12-volt chargers, putting out 62 amps if you need that much. If you're charging at a super high C rate, or multiple big batteries, or parallel charging, daisy chaining some boards together, this will put out enough amperage to do that. However, some of your chargers, and if you go watch Joshua Bardwell's video on these power supplies and charging, you'll see that in order to get the max performance out of some of your battery chargers, you do have to hit them with 24 volts. The 12 volt just won't give you enough power in the end. So these are 4mm bullet connectors. I made up a little jumper here. So what we can do here is go ground from one to positive of the other. So now, get these wires untangled a little bit. Now we are in series, 24.78. So the amperage rating remains the same, still capable of about 62 amps, but we're supplying a lot more voltage to the charger. And if you look at the basic electrical laws, you can amps remaining the same, but the voltage goes up, means the wattage that you can use also goes up. So that's just a quick overview. Well, probably not so quick. We'll see how this edited video comes out. That's an overview of what I've done with these server power supplies. It's a really cheap way. I mean, back when I made my first video about how to convert that guy, I bought that new. I probably paid about $25-30 for that, I think. And then I had to buy a bunch of little the little connectors over here, some LED lights and stuff to light it up, let me know if things were running. If I had known then about these server power supplies basically having to be discarded at a certain number of hours, regardless of whether they were good or not, I would have just gone this way to start with. I enjoyed doing that, and that's cool. That thing works. It's still a good 12 volt and 5 volt benchtop power supply for me for testing things. But for charging, I'll be coming and using these. So again, in the description of this video will be a link to the video that I originally saw about how these were converted. Keep in mind that was for HP power supplies, and that was not these. These are Dell's. But I will also put a link to the RC Groups forum that has, I don't know, thousands of posts of what people have discovered and what they've done to figure out how these work, and the safety concerns. So that's a very good resource to go back to. The HP power supplies from that original video are still all over eBay. Same with these Dells. There are many types. That forum pretty much covers all of them. So if you found a good deal on eBay for a couple, but maybe they aren't these Dells, just go to that forum and look for the model number of what you bought, and there's probably a posting there that tells you how to activate it. Once again, keep in mind, if you're just going to use one of them as a 12 volt power supply only, then you don't have to modify it internally. You only have to modify the pins over here in order to get it to power on. If you're going to do the two supplies in series like this to get 24 volts, you do have to modify the DC grounding on one of them so that they can work together. It only has to be one of them, and you don't have to shrink wrap the second one. If I only had known, I could have saved some money not buying this large shrink wrap. But anyway, that's what I did. Wasn't that hard, and now I've got a 24-volt power supply set up that can provide all the power I need for that 500-watt iSDT charger. So thanks very much for watching. If you enjoyed this video, I know it's kind of rambling on, but give me a thumbs up. I really appreciate it. I'm trying to get my channel up to at least 1,000 subscribers so I can get back into the YouTube partner status and maybe start earning some more money back to the channel, because that allowed me to keep going on things like this. So I appreciate it. Spread the word, give me a thumbs up, subscribe to the channel, and again, thanks for watching. See you later.